Back again at the water's edge, Pacific Ocean, washing up on the Hawaii shores. Swoosh. One, two, three, four, five, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 1, 2, 3, 4. So I always have a sense of the rhythm going on here. The other day I was counting fast, counting the pace of the waves. Today I'm counting slower, and there's always the underlying rhythm, and sometimes it's slower, sometimes it's faster. Every once in a while it'll skip a step or adjust. So even though you can see a linear cadence, in a natural system like this where everything is wavering along the waveform, you should see wavering show up in everything, even in the core aspects of it where it's straight ahead. Direct linear measuring, like measuring the duration of the movement patterns, you'll still see a little bit of wavering. And I like to keep everything with a little bit of wiggle room, a little room to shift it this way, shift it that way, nudge it aside. But on average, over the long term, everything's conforming to that linear value. If you look at the waves themselves as they come in, you see they come in this way, but as a line. They establish a line, a straight line. Now, if you go out there and measure it, you're going to find that that line wavers. But it wavers on either side of what actually is a straight line and averages out to be something closer to a straight line than a scattered, random mess of progression. So we tend to think the water washing around is an expression of chaos. But is it? In the same way that where this washing around is the middle way between the ocean being out there and the land being up here, and where they meet expresses. And should we call that expression chaos? Or is the order in the wave system out there that you can count with regularity, a linear rhythmic progression? There's just a little bit of deviation over the long term of the durations. So does it have that order in it even where it washes around here? It does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's not really what numbers it counts up to from change to change or new set to new set. It's just the constant duration between each step. And so while I was counting, where the wave moves in. You can see that wave moving in, moving in, moving in. There's a pace at which it moves, which establishes a duration to where it splashes and then washes back. Then the next one moving at a pace with a duration between when it splashes and when it was there versus there versus there. Now, when it splashes and all that commotion comes up looking like chaos, all that swirling and intersplashing between everything, it fractals out. You can hear little splashings in between. After the big splash, you can hear little splashings in the mix. And if you've got a good musician's ear for polyrhythms, you can hear that the little stuff is geometrically fractaling into the rhythm pattern of the big one. And since we know that the rhythm pattern, by what we're hearing and what we're seeing, is established by the movement, and then the rhythm pattern fractals out into that stuff, you could see that the geometric patterning of the mass itself as it moves around, the geometric patterning of the pathway that it moves, has to have a fractaling type of order to it. If you can hear it in its movement, splashing around, swooshing, and all of that, you can go into that stuff and feel the movements too. And if you're good at feeling the movements, you can actually be down there in that dangerous spot. Imagine getting splashed against the rocks by that wave. That's very dangerous. But when you understand the movement, the music and dance of it, you can actually maneuver yourself to dance in sync with it. And the rocks that you're concerned about, you choreograph your movements around that and coinciding with the movements of the water, and there is a pathway to being safe. Some people would look at it as being a gamble. Some people make it out and some people don't. But even in the world of gambling, they take extra measure against card counters, people who have an understanding of what seems so random and chaotic, and can go in there and play the odds in their favor. There's an understanding to be had in the system. So it looks like a scattering of rocks, looks like a scattering of water. All that looks like a scattering. These rocks were splashed up here by the water. And I've tracked the placements of rocks, maybe not here, but in the more flat area of the beach. I've watched the water move and then watched the rocks that wash up on the beach and see that there's different sizes, and notice that the sizes of rocks vary according to where they come up on the beach. The bigger ones don't come up as far, the smaller ones come up a little bit farther, and the even smaller ones. And so it has a way of sorting rock sizes. So those rocks and sand down there, you don't see it here. What keeps them from washing up here? What makes them wash up there? Maybe they do wash up here, but the space is so open that the forces that wash them up are free to wash them back. Whereas here, the forces that wash them up aren't as free to wash them back, because when they wash up over this jagged berm here, when the water washes back, that jagged berm holds the flow of the water. So the force of the water that brought them up is blocked by that, and therefore the force in the water being blocked, that same force is what's carrying the rock. So as the force carrying the rocks is lost to the water, lost by the water, or lost from the water, then the rocks no longer have that force with which to travel back. That force was there in their traveling up, but then depleted as it hit the the berm here, and then to hit it again going back loses even more. And so you get the deposits to stay there. You also see that where you have two waves crossing each other. Sometimes you'll have waves wash up on the beach, and one will wrap around. The same wave will have a side of it wrap around and face the opposite side, where it also has a side of the wave wrap around, and then the two waves run into each other and splash against each other and cancel out a good amount of their forces. And any rocks that they were washing around in their progress to that situation, those rocks have the force which was carrying them, the force in the water, canceled out. And so now for the rocks to continue being carried by those forces, that's no longer available to the rocks. So the rocks drop right there. And so you'll see piles of rocks developing on the beach. And depending on the energy in the water, you'll see whether it's a pile of medium-sized pebbles or large-sized pebbles, or really big rocks that are hard to carry, something like a dumbbell weight rock, and even bigger depending on how big the waves get. Waves out here can come towering over here. That's how this whole area got carved out. Waves as high as a 3-story building, sometimes close to a 3-story building. So this is a scattering, but there's a plot to it. So I would call it a scatter plot. And that was one way of describing fixed dynamics in the scattering, that a rhyme and reason, what size of rocks or the weight of them versus the water that's moving them around. The weight of the rock can only be carried by water that has sufficient enough forces. So you can read the forces of the water to some extent based on the rocks you've seen it deposit. If it's really, really big rocks, you know big wave forces were acting. Big waves, big motion. So out there, that shoreline, those are really big rocks, which is why we can see them from here. And that looks like a straight line. So I showed that in a previous video where I used it as an example for what a scatter plot would be. So a scatter plot would be a geometric shape that is drawn or established by a scattering of parts and pieces. Oh, that was a good splash. I got splashed, so I had to move. But anyway, so I'm looking at that scatter plot. This scatter plot here didn't draw out a straight line. It's something more complex as this swirling. But on the larger scale, the scatter plot conforms more to a straight line, which would be the straight line of the waves moving in. And if it's not the case of being a straight line, then it would be the case of being a curved line. And if it's a curved line, you'd see a smooth line curving, but in this case it would be scattered points of rocks roughly conforming to a curved line. If it was a straight line situation, you'd see a scattering of rocks conforming roughly to a straight line pathway. And it's relative to the forces depositing them. So the wave here has some curved line progressions. The wave face can sometimes come in at a curve, which is what it does over there. Comes in at a straight line, but then curves around here. So you see the straight line there, and then you see it curving into here. That's not a 90-degree angle change from that line. It's roughly a curve. So the lines here are drawn in a scattered way. So people would look at that pile of rocks, and that's a chaotic jumble of rocks. So how do you read into the chaos? So with a basic understanding of scatterplot reading a scatterplot, so looking at the scattering and seeing what shape it matches, it's no different than looking at the clouds and seeing what kind of shape you can see there. Is that a donkey's head? Is that an angel's face? Uh-oh, is that Jesus up there coming to get everybody and maybe leave a bunch of people behind? Is he coming? Is he going? If he's going, am I left behind? Does it matter? Should I just go the Buddhist way and not worry? Anyway, all those questions in themselves become a scatter plot of reasoning. And you can navigate through that using geometric modeling. You know, what kind of shapes is it conforming to? What's the most likely shape it's conforming to? A straight line, a curved line? What kind of curve pattern is it? And read into it. Now, this is one perspective of that line. So I'm going to find a way around here to get up there and get a perspective that looks down on it from the top. So let me go make that move. I'm not going to video it because I've got to climb all this jagged stuff and be careful. I don't want to be holding up a phone when I need to be looking down at all of this. All right, so here we are on higher ground. It's just so easy to look at all of this and just think, what a jagged mess. You know what? It's just simple to sum it up in just one easy term that throws around easy like a ball, or boxes away easy like a shoe put in a shoebox. But there's rhyme and reason. The dominant forces defining all of this are the ocean right now. When all of this was set into place, the dominant force was the flow of volcanic lava. Magma came up, came out as lava and flowed down wherever it came up out of the ground, and then flowed downhill. Downhill always leads to the ocean, and then the ocean goes even further down. So at one point, the lava was the dominant force, but still, when it came here, it met the ocean forces, and then the two had to contend. And that in itself is its own story with its own complexity, looking very chaotic. But eventually the lava cools down. The water's here to help cool it down. The lava here at the water's edge would cool down faster than the lava further uphill. Water, we tend to use water to cool things down. That's just the physics of it. Water likes to cool things down, if not put the whole fire out. So after the lava cools down, it's just a rock face, a rocky shore. And then the ocean has time to work on it. And I talked about these rocks, how they've been rounded off. There's a way that gravity takes part in the whole system and wants to leave a signature of rounding things off. You can look in outer space where all you see is the mass and all these things rounding off, but you don't have ocean water there washing them into a rounded state. You don't have winds rounding them off into a rounded state. Gravity by itself just sets that definition of shaping as it brings things together. So here, jumbling rocks together, but also shattering them apart. Even as shattering them apart and moving them apart, it washes them around and still they come together. And in that washing around and everything that it does, gravity is playing a part. The fluidity of the water, the crystalline structuring of the rocks, all of that meeting, and somewhere in the middle of all of that, maybe there's more dynamics to it than that, but in complex systems, you just start with a few dynamics that have some regularity to them. latch onto those and follow their pathway for understanding the system until you get a good sense of it, and you can just flow with it like a song and dance, and then progress from there deeper into more dynamics to see what's going on. So we're here to look at the scatter plot. We looked from one perspective, that shoreline of rocks, and you can see the straight line and a scatter plot of a straight line. And what the scatter plot means is that it's not quite straight. You see jaggedness. Droop, 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 in, out. But on average, it roughly averages out to what is a straight line. You can navigate a straight line along it and stay the course of that shoreline and find exactly where the safest straight line would be. Or if you navigated a meandering course through it, you would navigate somewhere between a straight course and changing direction course, a course that changes directions. Now all of that scattering together, if you drew that straight line to it or through it, along it or through it, and then measured distances between all the rocks at the leading edge where the water comes in. The water's the one coming in at the straight line. You would see that it averages out, those distances average out to be closer to what defines a straight line versus not defining a straight line. That's where the water meets the land. But you'll see the scattering of rocks goes in further, and you can see that how much farther the rocks are deposited inland is roughly even, because the forces depositing them, picking them up and moving them that much further in, come in rather even. That regularity of the ocean where you can count 1, 2, 3, 4, 5. That regularity, I'm not sure I was on it that time, but that regularity is a function of the mass in motion. The movement moves at a pace, and in that pace is the function of duration, time. And all of that together makes the rock solid equations for force and energy, meaning every time you'll have the same energy if you have every time the same amount of mass and the same amount of motion, or you'll have the same amount of energy every time if every time you reduce the mass you increase the movement, the motion, or every time you increase the mass you reduce the motion. You reduce them within a middle way balance to keep the energy the same. And that's how an equation ends up being in itself a middle way modeling. Two sides of the equal sign is the workings of an equation, and the equal sign being the middle way of what the equation is. And so it's mathematics that way, because out here the way dynamics function, trading off between each other, if the waves aren't so big but they're moving faster, they can have a lot of force. If the waves are big but not as fast, if the waves are bigger but not as fast, they can have the same amount of force as the waves that were smaller but moving faster. Force or energy. And so you can reduce the mass but increase the motion, or reduce the motion and increase the mass to keep a balance. Do something to one side and do something reciprocal to the other to reflect around the end result, which is the energy or the force. And so that's why the equations are structured in a middle way type of functioning, because it's just reality. Before there was math, before there were people here to look at this, before, who knows, there was life, all of this middle way dynamics was going on. Before there was such a thing as thinking, and before there was a mind or brain to do it, all of this was going on. The very root of the mind, of logic, is just there, as it's always been. And even before the earth was here, the dynamics that are governing everything going on here were out there, just waiting for the situation by which to express. So scatter plot type of reasoning, I brought that up because that's a very important navigation tool. When you see something that makes you think chaos or randomness, just immediately bring up the mind of scatter plot dynamics and look for what kind of shaping it reminds you of. That's the reason why we're artistic minded about looking at the clouds and looking for what kind of faces and interesting things to amuse us. As playful and artistic as it may seem, it is playful and artistic. And we come out here and play in the water. I'm playing on the rocks, getting my feet conditioned to the jabbing, sharp edges on these rocks jabbing into my feet. So I'm adapting or adjusting to feeling that pain, and in a while I won't feel it so painful anymore. But underlying it all is also logic, math, physics, and we make all kinds of philosophy around this. We make philosophy around what water does, how it moves, and all of that. And so reading scatterplot logic into the scattering of rocks there, which have their own deeper dynamics for why they're all deposited in the way that they are, beyond just the straight line, the linear alignment of the face of the scattering. In the scattering itself, there's a distribution of the rocks in the scattering. And if you go in there and look at the rocks individually and collective groups, maybe how far, group them according to how far up they are, you'll see a change in size of rocks. You'll see distributions according to shapes of rocks. So as scattered and chaotic as it looks, there's fractioning going on in there. It just gets more and more complex at how you arrived at that geometry of fractioning. So we'll just say, oh, it's just a fractured mess. And that works. We have an innate interface with all of this, where we don't need to know it, we don't need to understand it. We are geometric functions in our own living form and function. And that has evolved among all of this to be something that can be alive among all of this and evolve further among all of this. And being able to think about it as well and rationalize, that's another evolution in the art of being among all of this. Science to me is just another art of being among all of this. So the scatterplot dynamics. Now when you look at that, are you going to start looking for patterns in the same way that you look at clouds? Oh, is that an elephant face, a donkey face? That's one way of exercising the function of the mind. And in there are more mathematical patterns to find, and those mathematical patterns will be the windows and doorways into the physics, form, and function of what's going on where the water meets the shore and becomes more turbulent, and so you can predict by all of that, start to predict what's going to happen before it even happens. So we tend to think chaos when we don't have predictability about what's going on. And yet a lot of things we can say predictable, and like everything, consistency of a straight line, there's going to be wavering. Consistency of predictability, there's going to be wavering. But 9 times out of 10, we are on course to what's been established predictably. And then every once in a while, wavering. I'll say, you can't predict anything because you don't even know if you're going to be here tomorrow. The whole world could end tomorrow. But looking at it statistically, you've lived your whole life, all day, every day, for many, many days. And only one day are you going to die. So if you lived 1,000 days, 10,000 days, 100,000 days, whatever it is, and only one day you die, that is mathematically positive, just a little bit, tiny, insignificant bit shy of 100% predictable that you're going to live another day. It's just going to be maybe just one day that you don't live another day. So overall, in the big picture, there's always another day. And then even if you don't make it to another day, there's still going to be another day there, and there'll be other people to example that yes, there is another day, on and on. And then if it's the whole world that ends and there's not another day, you look far enough out there, maybe your soul goes onward, and there's many, many worlds out there upon which there will be another day, and many, many, many other days. And so in the Buddhist philosophy, they'll talk about other lifetimes. Now, do other lifetimes also imply other worlds? Other lifetimes on other worlds? So there's always a bigger picture. We could go to that shoreline and scale down to the smaller picture of each individual rock and the distribution. We could go down to the water and scale down, not just from the wave that washes up and breaks up, but scale down into all those little patterns of whitewashing and see stuff going on. We can scale upwards, along the scale of the whole island. And this little curved cove that we see here that is distinctly curved, how could we define that as anything else other than roughly a curvature of which the whole beach bay curves? Bays tend to do that anywhere in the world, large scale globally. You'll see that curving pattern of bays forming. That's another dynamic of physics where the water meets the land or the land flows to meet the water. And then scaling up even larger for the entire Earth's tectonic gridwork, fracturing of the geological surface of the Earth down deep. And then you get a system of crashing and splashing of earthquakes and volcanic eruptions splashing up. And underneath it all is something. And underneath it all implies underneath this very ocean where all this movement is going on, and underneath it all is something driving up the earthquakes, driving up the volcanic eruptions. This land is here as a function of a volcanic eruption, putting it here. And that stuff going on underneath it all moves the tectonic gridwork for earthquakes and volcanic eruptions. But that motion doesn't just disappear, it transfers, it moves into something else, and it moves into the ocean. And suddenly we no longer are looking at waveforms like we see here, waves coming in, where we're looking at this and deciding how to read into it. You can have waves that are tsunamis. just wash in and devastate. So I don't need to explain what that is. That's such big news when it happens that we've all kind of gotten the news in the past before. Or you can go to YouTube and look up tsunami devastation scenes if you want to see what it does and what it looks like. And there's predictability in how far up a tsunami would wash if it came from such and such location at such and such content of force in its body of water movement and the earthquake that pushed it up and all of that. So the bigger the earthquake, the bigger the tsunami it can generate. But sometimes you can get, say, a 7.8 earthquake make a tsunami for one place, and the same magnitude of earthquake in another place under the ocean not make a tsunami. So geometry of where these occurrences happen. So things are moving in a dance, and the dance implies geometric form. It moves within a geometric form and moves to a geometric form. It moves by a geometric form. Just everything geometric through and through. Even the aspects of it that are unseeable, unmeasurable in a tangible way, they all have geometric relationships. Energy in itself, where is it? How do you touch it? How do you hold it? How do you weigh it? And yet, its function can be defined by geometric relationship between mass and motion. And so geometry is the clue there. And geometry between mass and motion, in between, that middle way. And so geometry and middle way is that navigating course through it all. And navigation is much more than just straightforward point A to point B. It's a 3-dimensional, 4-dimensional, and many more dimensions going on, and the way that you can navigate, calculate, proceed, construct, architecture, do all of that through it. It's amazing. So this was the segment delving into scatterplot perspective, to have a scatterplot reasoning about your perspective of things, especially when it comes to chaos. What kind of scatterplot is it, rather than just dismissing it as something that can't be made sense of? And at the very basics of it, like looking at the clouds and looking for a pattern in the scattering of the clouds to see what you can see. Maybe trying not to be as far and wide daydreaming about it. But still, imagination has to be a part of it. So as an important tool for navigating complexity, scatterplot reasoning as an important tool for navigating complexity. That's why I brought up scatterplot, the idea of scatterplots, and talked about their application, and basically all for helping to navigate through complex systems. And not necessarily that we are going to navigate through those rocks because we want to be up in those rocks, enduring whatever danger or challenge they have, but just for understanding that helps us to plan whether to be there or not, or what we can put there or not put there, or to expect whether that scattering will be there next time or not be there next time. If we look closely, there's a swimmer out there. That jagged edge. of what would otherwise be chaos. He's navigating. He's navigating. And there's a plot to it. As scattered as it may seem, there's a plot to it. And there's predictability to be had in that. And in that predictability, he can plot and plan and know his way in and out of there. And there is a cadence, a timing. When do I make my move? When do I back off of my move? And you look at that, it's all working out. And it's the swimmer's dance. Some people get in there and they don't do their dance so good, and they don't make it. So it's about how you read into it. Do you look at it, oh no, it's chaos, nothing we can do about it, lost cause? Or it's a scatter plot. There's a rhyme and reason in it, and if I could just find that rhythm and do my dance and music to it. See that big wave coming in? And he's right there where he needs to be, where the wave peaks under him rather than over him to smash down on him. Timing, as in a dance, as in a choreography. And that system by which he operates to have that ability to make it through is a geometric rationing. And it's the same thing that goes on in the land, regardless of whether there's anyone there. It's working there. It's always there. And he comes and applies his own geometric form and function to match and sync with that. And that's harmonic functions going on. Harmonic functioning. So scatterplot reasoning, I think I'll end it there. It's a very good tool for navigating one's way through complexity. There he is. He had his good time in there, and he's swimming back, and he's swimming back.